Hi, welcome to Lecture 4, Part 4 on Basic Inorganic Chemistry. My name is Dr. Teresa Chimamanda. So today I will be discussing about compounds. So a compound is a substance formed when two or more chemical elements are combined together. So for a compound to be formed, there must be at least two or more elements, and the two elements must be different. If the two elements are the same, it cannot form a compound. An example is pure water. Pure water is a compound made from hydrogen and oxygen to give water molecule. So you can see that there is hydrogen here and there is oxygen here. So these two elements are different. Therefore, water is a compound because it is made of two different types of elements, hydrogen and oxygen. Another example of compound is carbon dioxide. Carbon dioxide is a compound made from carbon and oxygen. Again, carbon is different from oxygen, so it can then combine to form a compound known as carbon dioxide. So for a compound to form, there must be at least two different elements. So now we look at homogeneous and heterogeneous solutions. A homogeneous solution is a solution that is uniform. A homogeneous solution is a uniform solution. This is an example of a homogeneous solution because the solution is uniform. It forms a very clear solution. There is no precipitate in the solution. The solution is uniform. Therefore, it is a homogeneous solution. A heterogeneous solution is the opposite of a homogeneous solution. So, a heterogeneous solution is a non-uniform solution. This is an example of a heterogeneous solution. You can see that the solution is not uniform. It forms three layers, 1, 2, 3. So, it is not a homogeneous solution. This solution is an example of a heterogeneous solution. So we now look at pure substance. What is a pure substance? A pure substance is a substance with a homogeneous chemical composition. So any substance that has a homogeneous chemical composition is known as a pure substance. So all the chemical elements are examples of pure substances. So all the elements like hydrogen, nitrogen, oxygen, helium, iron, argon, calcium, potassium, all the 118 elements are examples of pure substances. Now we look at how to recognize pure substances. Each substance has a set of properties that are typical of that substance, which gives it a unique identity. So, each substance must have a set of properties which are typical of that substance, and this is what makes that substance unique. The individual properties of each element can be physical properties and it can be chemical properties. So let's look at physical properties. We use physical properties to describe matter. Physical properties are properties that you can see, you can visualize them, and you can also measure them without altering the composition of that substance. So physical properties are properties that you can see by mere looking at that substance, or you can measure them without altering the composition of that substance. Examples of physical properties are appearance. So by looking at a substance, you can say some of the physical properties like the way the substance looks, the shape. You can describe the texture by mere looking at it. You can describe the color. You can smell it, and you can describe the odor and many others. So physical properties are properties that you can see immediately or you can measure without altering the composition of that substance. So for instance, your physical properties might be that you are tall, slim, you have long hair. So these are physical properties, properties that you can see and properties that you can measure without altering the composition of matter. So now we look at chemical properties. A chemical property can only be observed when a chemical reaction is carried out. So you cannot observe any chemical properties by mere looking at that substance. You must carry out a chemical reaction before you can study the chemical properties. During a chemical reaction, the arrangement of atoms within a sample is interrupted. So when a chemical substance undergoes a chemical reaction, its structure is interrupted. This then allows the chemical properties to be investigated. Examples of chemical properties are rusting of iron. This is the equation for the rusting of iron. Another example of chemical property is change in oxidation states during oxidation reactions. So during oxidation reactions, the oxidation states of elements change. So this is also an example of chemical property. So this is where I'm gonna stop for today's lecture. Please like this video and subscribe, and I'm gonna see you in the next lecture.